Hi, hello to my Physics 2211 Lab 5 collisions. And so this project models a two-car collision using GlowScript to analyze how momentum, force, impulse, and energy behaves during an impact. And so I want to start off with a question, which is why are car crashes dangerous? Well, in a car crash, vehicles experience rapid changes in motion, and the key to this question is how fast one's speed changes and the force acting during the collision. And so this project investigates how changing mass, speed, and collision time affects momentum transfer, force, impulse, and energy during a two-car collision. And in terms of some physics principles, we have momentum, which is mass times velocity. And so each car has its own momentum, and the total system momentum is the sum of both momentums. We have the conservation of momentum, which states that in an isolated system, the total momentum before the collision equals the total momentum after the collision. We have force and impulse connects force and momentum, and the force during a collision depends on how quickly the momentum changes, depicted by delta t. And kinetic energy depends on velocity squared, and so this means that the higher the speed leads to a much larger energy change compared to a larger mass. In terms of predictions, my model predicts that the total momentum will remain constant and the forces will be equal and opposite due to Newton's third law. Impulses will match changes in momentum, and kinetic energy will decrease for inelastic collisions. In terms of my code, I created a GlowScript simulation where the two cars move towards each other, collide, and then move apart, and the collision is modeled over a short time interval. And here's my code that I ran for my lab. And here's a little video of what it actually simulates. When we made the masses the same, but increased car's one speed by a factor of 3 compared to car 2, we see that the acceleration is the same due to it having the same forces acting on each other and the same mass. In terms of velocity, car 2 and car 1 experience similar changes to velocity. Delta KE, we see that it's the same, that it is not zero, so it's inelastic, and impulse is also the same. Now here, when we make the collision time larger, keeping the masses the same, we see something different compared to the other three graphs. We see that the time that it takes to reach the final state of like velocity or acceleration, we see that it has a slope, which corresponds to the fact that a larger collision time gives the momentum, makes the momentum more spread out. So for no collision time, we see that it just spikes up and without any dampening or anything, which is not safe for drivers. And for impulse, we see that it's zero because if impulse is force times time, and if time is zero, then impulse is zero. And in terms of results, the results match the physics model. Momentum is conserved, forces are equal and opposite, and energy decreases in inelastic collisions. And so these results explain real-world car crashes. Larger forces and accelerations increase risk injury, while energy loss represents deformation and damage. So some sources of error. My model assumes constant force and ignores real deformation, so it kind of simplifies the car crash behavior. And if speed increases, energy increases significantly. And if mass increases, the heavier car dominates in the collision if speed doubles. But if mass increases, then KE is proportional to M. Compared to if the speed doubles, then KE is proportional to V squared. And if collision time increases, then the force decreases, which leads to a bigger delta T, which leads to a smaller force. And so the same momentum change spread over more time, which leads to a safer car crash. And so, in conclusion, this simulation demonstrates that physics principles accurately describes collisions, momentum is conserved, forces follow Newton's laws, and energy changes explain real-world effects. And so, increasing the collision time reduces the force experienced during a car crash, even though the change in momentum is the same.